In section 2.3, we look at organizing quantitative data. So we're going to have three different grouping methods. The first method is single value grouping. The second method is limit grouping, and the last is cut point grouping. The first two we use typically with discrete data, and the last would be with continuous data. Now, there may be opportunities where the limit grouping may be used with continuous. With single value grouping, there are discrete data and not so many that each data value can't be its own class. Whereas with the last two, with limit grouping or cut point grouping, then the range of data is just so big that it's more feasible to divide the data up into classes. And so each specific data value cannot serve as its own class. So an example of single value grouping would be what we see here, the number of TV sets in a household. And you can see that 50 households were randomly sampled. And so the data value ranges from 1 to 6. That's not too much. And so each data value itself can serve as the class. So here we have a frequency distribution and a relative frequency distribution for this data. And again, this is single value grouping because each data value serves as its own class. Okay, the next method, the middle method, was limit grouping. And with limit grouping, typically this would be discrete data. Then we have a lower class limit and an upper class limit. With each class, the lower class limit is the smallest value that can go in that class, and the upper class limit is the largest value that can go in that class. And then the class width is the difference between consecutive lower class limits, or you could also do consecutive upper class limits. And the class mark is what you get if you average the two limits of a class. So let's look at this example related to short-term investments. In particular, we're interested in the days to maturity for some short-term investments. And so you can see just by scanning the data, it looks like, let's see, what's the smallest? Maybe the 50, no wait, there's a 36. I think that's the smallest, and then I don't know what the largest is. I see a 99 here. Okay, so the largest is 99. So the range of the data is 99 minus 36, which is 63. So that's just too much range to do single value grouping. But since we're still working with whole numbers, we can use limit grouping. And so here you can see in table 2.7, this is one way that this can be done. This seems to be a pretty good way to divide up the classes. But notice that with each class, there is a clear lower limit and a clear upper limit. In other words, with each class, there's the smallest value that can go in that class, and then the highest value that can go in that class. When you deal with continuous data, often you need to do this third method, which is cut point grouping. With cut point grouping, remember with continuous data, that's data that can take on values in some interval. And so here we talk about cut points. There's the lower class cut point, which is the smallest value that can go in a class. And the upper class cut point, and see here's where the difference comes in. The upper class cut point is not the largest value that can go in that class. It's the smallest value that could go in the next higher class. Because with cut point grouping, there essentially is no highest value that can go in a class. Okay, and then class width is very similar. It's just the difference between consecutive cut points and then the class midpoint is the average of the two cut points for any class. So again, we use cut point grouping when we have continuous data such as weight. So here we have the weights of males age 18 to 24 years of age. So here is in table 2.9, here is one way to divide up the classes. And so notice that in the first class, the lower cut point is 120, and the upper cut point is 140, but the number 140 cannot go into the first class, that has to go into the second class. And so that's the distinction between the limit grouping and cut point grouping. But then once you specify, what constitutes each class, then it's the same as before. You compute the frequencies and the relative frequencies. Okay, once we have the distribution described in some sort of grouping fashion, then we can go a little further and put together what's called a histogram. And we can do a histogram for any three of the grouping styles that we looked at. And so what a histogram does is it displays the classes in sort of a visual fashion. Let's look at figure 2.4. In part A, we see that the number of TVs histogram is given. And so a histogram does a much better job, in my opinion, of displaying the distribution of the data than does the table, because we can clearly see where is the highest bar, and then we can sort of tell the distribution of the data. Notice that there seems to be the tail seems to be a little more stretched out on the right here. Here we would say this is skewed to the right. We'll say those terms later. And the relative frequency gives us the same picture, essentially. Okay, here in figure 2.5, remember we looked at the investments and the number of days to maturity for the investments. And we've got a frequency histogram and relative frequency histogram. Where the bar is located indicates, where that class starts and where it ends. So this class started at 30 and ended at 40. Well, ended at 39, actually, in the first class. And again, we see a similar picture with the relative frequency histogram. Okay, and lastly, let's look at histograms for the data we looked at with cut point grouping. And so remember, this is continuous data, the weights in this case. And like I mentioned earlier, once you get past how to divide up the data, what kind of data we're dealing with, and which one of the grouping methods we need to use, the steps to put together the histogram are pretty much the same. So we've seen that histograms are one way to visually display data. Another plot is what's called the dot plot. And with a dot plot, we draw a horizontal axis and we make sure that the entire range of the data is taken into account. And as its name implies, we essentially put a dot. These dots are stacked on top of each other at each data point location. So when I look at this dot plot, for example, this part here, then that tells me that 219 occurred 3 times in the data set. And sure enough, there's 219, and let's see, the third one is right there. And so the dot plot does an acceptable job of displaying the distribution of the data as well. Perhaps the best plot is the stem and leaf plot. So let's consider this example of the investments. We take the tens digit and make that the stem, and then the ones digit, and that will be the leaf. And you can see that in part A, unordered. And then in part B, what's been done is the leaves have been ordered. And the reason why I said earlier that this is perhaps the best of all is because it gives, number one, the ability to reconstruct the entire data set, right? If we started with the stem and leaf plot, then we know exactly what data values were included. And secondly, it gives us an idea of the distribution of the data, because if you turn your head to the right, or if we could take this screen and rotate it 90 degrees to the left, then when we look at the rises and falls of the leaves, then we can sort of see the layout, the distribution of the data. So in essence, we've got the ability to recover the data completely, and we've got a visual display of the distribution of the data. Another example given here in table 2.13 and figure 2.9 deals with cholesterol levels. And what's being illustrated here is that what's the stem and what's the leaves, those things can be done in different ways. In part A, every digit except the ones digit is taken to be the stem, and then the ones digit is taken to be the leaf. Whereas in part B, every digit except the ones digit is taken to be the stem, but we have two stems. For example, the 19 is included twice, and so the leaves that would go with the first 19 would be 0 through 4, and then the leaves that would go with the second 19 would be 5 through 9. So in part B, we're using 2 lines per stem as opposed to 1.